Yes, class. So in the last class yesterday, we had started with thermodynamics. Now, see, in this section, which we had discussed yesterday, even in this section also, some of the concepts of kinetic theory was used. So what we'll do before moving on to the second law and completing with Carnot engine and refrigerator and all, there, because you'll be using kinetic theory, and because of the holidays, last 2 days we didn't have the class, no, last Saturday and Sunday. So that class will be taken within this week only, upcoming week. So before then, at the last, in the last class, we'll complete with this thermodynamics. But in today's class, we'll try to start with kinetic theory. Today and tomorrow, we'll try to complete kinetic theory, because thermodynamics is linked to kinetic theory. So once you are thorough with KTG, then you'll be able to understand thermodynamics. The way yesterday, so many things were getting used. Degrees of freedom, postulates were also getting used of KTG, the formulas and the laws of it. So that's why. But regarding the topic that we have completed yesterday, some of the questions were left from this topic as well. So let us complete the questions from this topic, then we'll revise kinetic theory. Most of the questions we had completed, some were left. So see, this says that it will be a revision of the sign conventions which we had used yesterday. So this is saying, during an isothermal expansion, a confined ideal gas does minus 150 joules of work done against its surroundings. So this implies that 300 joules of heat has been added. No heat is transferred because it is isothermal. 150 joules of heat has been added, or 150 joules of heat has been removed. So firstly, we have to find out the magnitude, and then whatever is the sign coming by default, that we have to utilize. So see, if we apply the first law of thermodynamics, what was the first law of thermodynamics? Delta Q was equal to delta U plus work done. What was delta U in this? What did delta U denote?
Change in energy.
Change in internal energy. See, this is heat energy. All are energies. This is also energy. This is also energy. This is also a type of energy. So this is heat energy. This is internal energy. And this is the work done. So delta U is equal to delta Q minus work done. Now see, if this is isothermal process, because this is mentioned in the question that during an isothermal expansion. So it means if it is an isothermal, yesterday I have told you in isothermal, one of these quantities becomes zero. Which quantity is it? For isothermal process, out of all these three, one will be zero when temperature is constant. Internal energy. See, for isothermal process, internal energy becomes zero. As I've told you, this is a function of time. This is a function of temperature. So when this is a function of temperature, if temperature isn't changing, internal energy becomes zero. So if this term is zero, so you are left with delta Q only. Delta Q is equal to negative minus of work done, right? From here, this is zero, so delta Q is equal to minus of work done. Now, see, so work done is what? It is given minus 150 joules. So delta Q will become minus 150 joules. This becomes plus 150 joules. So it can be C option, it can be D option. That is because of the magnitude 150. But we have a positive sign, and positive sign shows that heat is added to the system. So added is C option. So this is C. Note it down.
Ma'am, delta Q should be positive work done, right?
Delta Q is positive work done, but in the question, this is already given negative. So that's why this work done's value, we are writing it as minus. Otherwise, if this wasn't specified, we would have used a general equation. Since it is given, already it is given negative. That's why I've used negative. Otherwise, by mathematics, if you directly put, this would be positive. It would directly be equal to it because this term is zero. That's why. Fine.
Yes, ma'am.
See, class, this is a very easy and a very short question if such types of questions come. See, just now also we had used the equation delta Q is equal to delta U plus work done. So if it is saying, it is giving you a relation between delta Q and W, it means delta U and W means this term is zero. That's why some relation is there between them. Right. So first thing from here only you can conclude if delta Q is zero, which process will it be? Isothermal or adiabatic? Yes, class.
Adiabatic.
It would be adiabatic, right? Because in isothermal, above also I have discussed with you, in isothermal delta U is zero, and in adiabatic your delta Q is zero because there isn't any heat transfer now. That was the definition of adiabatic. So if this is adiabatic, Wait. This is adiabatic. Now, it means this is a non-conducting wall. Heat isn't getting exchanged. So it can be either option A and it can be, or it can be option D. So how will you determine if this is 0? Delta U and delta Q both will be negative of each other. They cannot be equal, right? Because nothing is mentioned about whether work done is positive, negative. In the previous question, that's what I was telling to say, that in the previous question, it was specified that work done is negative. It was given. Here, this is a generalized question. So this means A option. Quickly noted. All of you try this question 19. Let me know whatever options you're getting as your answers. After this, we'll discuss kinetic theory. So this is the last question from this section of first law and the processes. Try it by yourself, then we'll discuss. And send me your options in the chat column. Swaptil, only Alan and Hanifa have answered. Alan's answer is correct. All of others also try this. There will be confusion only between two options. At least reach that stage. Firstly, use it for isothermal expansion. Okay, last 2 minutes, then I'll discuss it. And whoever is getting the answer, please share it. Write your option. Initially used for isothermal, use a simple equation P1 V1 is equal to P2 V2. From that, get the pressure and then apply to adiabatic equation last. In the last class yesterday, we have written certain equations for pressure, volume, and all using gamma, where gamma was involved. So gamma is also mentioned. C class. So all of you have got correct answer. Yes, Hanifa, now your answer is right. Saifullah's answer is correct and Alan Jason's answer is right. See, for the first part, no, monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V. Then adiabatically. We'll leave adiabatic right now. Let's jump to isothermal. So for isothermal process, C. For isothermal process, delta T is 0. There isn't change any volume. Temperature. It means temperature is remaining constant. This all we'll discuss in today's class in kinetic theory. That's why I want to do kinetic theory first. So in this situation, pressure and volume both are directly proportional to each other. Both are inversely proportional to each other. So when we will go here, P1 V1 is equal to P2 V2, because from here you can conclude that PV will become constant. This is the case. Now pressure 1 is given P, volume 1 is given V. See, all these values are given in the question. See, this is pressure 1, this is P, volume 1 is also given V. Pressure 2, P2 is unknown, and volume 2, this is given as 2V. So what is unknown here? Only P2 is unknown. So first task is to find out P2, which is missing. This becomes PV equal to P dash. Let me mark it as P dash into 2V. Right. So VV gets cancelled. Pressure becomes P divided by 2. At least we have now the values. Now coming back to the question. Initially, the question was mentioning that this was early isothermally. Now this is adiabatically to a volume 16V. So now this is going to a volume 16V with gamma is 5/3. Now see, for adiabatic process, for adiabatic processes, PV to the power gamma, this remains constant, right? So how do we write it? P1 V1 to the power gamma equal to P2 V2 to the power gamma. Now again we have the values of everything. See, now for us the pressure that is provided, this pressure, we have calculated it, P by 2. V1 is also V1 is 2V, right? 2V is given. P2 this, we have to find it out, P2, this is unknown in this. And V2, is it given? Yes, it is 16, no? 16V. So this becomes 16V and gamma is given as 5/3. So again, one quantity is missing, that is P2, which we have to find it. So if we substitute P by 2 into 2V to the power 5/3 equal to double dash, let me make it P double dash in order to distinguish it from the pressure that was given in the above part, into 16V to the power 5/3. P by 2 into 2V to the power 5/3, and P is equal to P double dash 16V to the power 5/3. Now this we have, and we have to solve, we have to find out P double dash in terms of P. So what we can do, 2V to the power, see this is given, at least we can bring these terms together so that we can solve it together. So P by 2, 2V by 16V to the power 5/3, this is P double dash, this is easier to solve it. VV also gets cancelled from here, and this becomes 1/8. So P double dash, this becomes P by 2, 1/8 to the power 5/3. So 1/3, that is cube root of 8, that becomes 2. So P double dash, this becomes 2, and this becomes 1/2 to the power 5. So this becomes 32, and 32 into 2 is P by 64. So 1/32, and this becomes P double dash becomes P by 64. So it was option C, I think, the question. Yes. So option C is that. Note it down, class. All right. So regarding the theoretical part of kinetic theory. So here you have to understand the laws that we have been using, but we're not aware of which law is the. So ideal, when we talk about ideal gas, an ideal or a perfect gas is that in which obeys all the laws at all the temperatures and pressures. So you mainly have three laws which you have to remember. Out of all these quantities, PTV, one will remain constant, others will have their proportionalities. It can be directly proportional to each other, inversely proportional to each other, this depends. And ultimately you get the ideal gas equation. So for Boyle's law basically says that if temperature remains constant, so pressure is inversely proportional to volume and PV is constant. So it means if pressure is increasing, volume will decrease. Or if volume is increasing, pressure will decrease. So the graph is also a hyperbolic graph, which shows that both are inversely proportional to each other. Then you have Charles' law, because these laws are mentioned and some questions are there directly on these laws. That's why, and very simple questions are there from these laws. So Charles' law says that pressure will now remain constant and volume and temperature will be having their proportionalities. So pressure remaining constant, volume of a given mass is directly proportional to its temperature. This is what is meant by this. So suppose if this is a point, if I choose, this will be value of temperature, this will be value of volume. If I choose this point, this will be value of temperature, this will be value of volume. So they're having the direct proportionality, means temperature is also increasing, so volume will increase. If volume is decreasing, temperature will also decrease. And then you have Gay-Lussac's law. In this, volume remains constant and pressure and temperature are directly proportional to each other. So in this, what happens? If pressure is increasing, temperature will increase. If temperature is increasing, pressure will increase. Both will this happen. Or if pressure is decreasing, temperature will decrease. Direct linear proportionality. So if we combine all of these, we get this equation PV is equal to nRT. N is the number of moles. R is the universal gas constant. So you will be using two values of it. R as if see SI unit is joules per moles per Kelvin. So in questions, how to decide whether to use 2 calories per mole per degree Celsius CGS unit or to use 8.314 joules per mole per Kelvin. You will see other units. If the energies unit is mentioned in calorie, directly use 2. The answer also becomes easier and the calculation is also trivial. So you'll have the options, and in options, if you see the final unit is given in CGS, then directly put it as 2. If not, then put it as proper 8.314. Many a times by just putting 8 also you get your answer around the options. Because see, if options are very different from each other, then even if you land up near the option, one of the options, you'll be able to guess its correct answer. But see now, if all the options are very closer to each other, like 2, 2.1, 2.3, like these, or if options are present, then you cannot round it off and get the answer. Then you have to use it precisely. So just to write down these following basic laws, because just mark it as, make the heading as laws, and do not write all this. Just write it from the laws directly, quickly. Just this part, no need to write the theory line and the graph. Then this part and the graph. And this also please write. Now you have certain postulates of KTG. This you have to remember. So all those things that I have marked with red, just you have to note it down that part portion only. Just remember, large number of identical molecules are present. All right, all of them are in random motion. Now, if you look at the size of the particles, the sizes are very small, but the distance between them, this is also very less. But if you compare it with the size, the relative size, then you'll notice that the separation between the particles is very huge. See, if you take two particles, it would appear that they are at this separation, only this much distance. But if you look at microscopically, this is how two particles will look like, because since they are so small that the relative separation between them becomes greater. And it is all the particles are treated at small point charges, point spheres, hard spheres. And perfect elastic collision occurs between them. Work, energy, and power, you must have studied perfect elastic collision and elastic collision. You have written also elastic collision in the last classes when you're doing work energy. And yes, this I was mentioning you, this is the most important point which is used actually out of all the postulates of kinetic energy. Postulates are asked as in the statements questions. Statement 1 and 2 will be given, all the statements will be given, all the postulates will be given. You have to identify whether postulates are correct or incorrect. So no force means, see, these particles are actually not exerting force on each other. Force of it, when forces get exerted, then we have the concept of potential energy in the system. But here, since force is also not isn't working, so potential energy also isn't present. So since the particles are in random motion, be it whatever type of kinetic energy, rotational energy, just the vibrational energy they are possessing, or normal linear kinetic energy they are possessing, all will be in terms of kinetic energy only. This portion will be absent. And it obeys Newton's laws of motion, means you can apply, if acceleration is there, velocity is there, you can apply F is equal to ma. External force will be required to move all the particles, and all the three laws of Newton's laws of motion will be used. Law of equipartition of energy, here you just have to remember some formula. See, just remember kinetic energy's formula, one more formula, if Boltzmann constant is given to you, is half kBT. Fine. Now, Boltzmann constant value you have to remember. I think I must have, yes, 1.38 into 10 to the power minus 23 joules per Kelvin. This is the value. This value you have to remember, class, the value of Boltzmann constant, this value. And the another formula for this formula is also important. Kb by R divided by Na. Boltzmann constant is actually the ratio of the universal constant divided by the Avogadro's number. So universal constant is R. Universal gas constant is R, and Na is the Avogadro's. This is Avogadro's number. So 1.38 into 10 to the power minus 23. So kinetic energy becomes half kBT. This you have to remember. And see, this is the formula for internal energy actually. I was telling you, it's a function of temperature. So this is how you use, but you get the concept of degrees of freedom. This I'll tell you later also. So N, number of moles. N is what? N is the number of moles. F is degrees of freedom. R is the constant. T is temperature. 2 is the constant. So these formulas, out of all these formulas, this one is most important, and this one. This value you have to remember. Just note down all these things. Just all the things that are written in the box here, note them down, and all the points that are written in red under the red line. This one. Don't write the whole complete sentences, so that just you make bullets and just write down these main points.
Ma'am, can you scroll up, please? Ma'am, T here is temperature or time?
Temperature, temperature. This is temperature. Kb is Boltzmann constant. This is temperature.
Done, ma'am.
Sometimes in the question, this would be missing. Some out of all these quantities, one would you need to calculate, or the data will be given, use R as this, Avogadro's number as this. So don't use Kb, then put in the value. You can put the value here. So your equation can be half R by Na into T. This also you can use if needed, but mostly we have this. And this gets used in your semiconductor also, wherever kinetic energies have its multiplication, this is used. This is actually an important formula, this one. Yes, class. So if a question comes, this is also important, this also gets used a lot. Pressure exerted. So if pressure exerted is asked, then the whole formula becomes 1 by 3 m into n by v into v square. So now meaning of each term. T, this is the pressure exerted. 1 by 3 is constant. Small m, this is the mass of the molecule, not the mass of container. Two masses will be given to you. One will be the mass of this container and one will be the mass of the molecule. So this is the mass of molecule. Capital N, total number of molecules that are present, whatever is the number of molecules that are present. Capital V is the volume of the box. Volume of the box, volume of container. Volume is asked, volume of container, not volume of molecule, because both the things will be mentioned to you. And small v is the root mean square speed. This I'll tell you what is root mean square speed. First note this down. We'll discuss this because separate questions also come from this. Now see root mean square, you'll go it opposite. When this is asked, no, root mean square speed. So for root mean square, write it, see root mean square. So you will go opposite. First you will calculate square, then mean, then root. This way you have to do. So see if individual, these are all the particles that are present in a container. All these particles, they are present in the container, right? Now n number of molecules are present. So every molecule will be having its own velocity, n number. N is the total number of molecules that are present within the container. So v is the speed. So what do we have to do? Not root, not mean. First, we have to find out the square. So square each term. V1, so V1 square. V2, so V2 square. V3, so V3 square. Likewise, square all the terms. Then how do you calculate the mean value? If I give you three quantities and I ask you to calculate their mean, what will you do? You will add all these three and divide it by 3. Why? Because total number of molecules or particles were 3. Same thing here also. You will take the mean value. This is how you take the average, add all these and divide it by the number of molecules that are present. This is the total number of molecules, capital N. Now nothing, you just have to put it under bracket, that is under root, so this becomes the RMS. And so root, so square first, then mean, then root. So this is what is known as root mean square. This is the velocity which you have to remember. Now, one more thing, class. Volume can be written as L cube if volume is specified, because sometimes in the question it can happen that length is given to you and pressure exerted is asked from kTg, if this question comes from here. So for length you can do directly put V as L cube. This becomes the formula for pressure, and P is equal to 1 by 3 and N by V. Sometimes small n is used. This small n is number of particles per unit volume. So if just be careful whether it's number of particles per unit volume mentioned or only number of particles. If only number of particles are mentioned, then capital N will be used. Only this equation. If number of particles per unit volume are mentioned, then use this equation. Note down these equations. I think this isn't needed. Just write it from here. See class, this I have discussed with you, but I just wanted you to remember this. 3 velocities formulas you have to remember, apart from what we have discussed, because these are also used and lots of questions, ratio questions get solved using this only. So see, first is RMS velocity. One formula you have seen, that is the general one, actually breaking it down, jotting it. But if suppose mass of the molecule is given to you and rest of it is asked, so this you should know. Or let me give you the ratio only directly, so that in one line you'll be able to remember it. See, velocity, that is most probable velocity, most probable speed, we use MPS, ratio to average speed or mean speed to root mean square speed. This is actually, I'm writing it below only so that you remember, because their ratio is also asked. This is 2RT by M, where M is the mass of molecule, R is the universal gas constant, T is temperature, is 2. This is 8RT by pi M, under root, average one. And 2RT by M, 8RT by pi M, and 3RT by M is root mean squares. So if you take the ratios, lots of questions are there in your previous year questions where this option is directly given. So no need to waste your time in solving. Remember this. It would be root 2 is to under root 8 pi, 8 by pi, and is to root 3. Or even if it is given in decimals, so 1.41, this you remember. This is 1.732. This also you remember. Under root 8 by pi, this is around 1.596 around. So their ratios can also be asked. The values also can be asked to write it down. All right. So this is asked. This from your kinetic theory, these types of questions are asked. So note down this page as well. And lots of ratio questions usually come. Done class. So C class, I'll take the questions because we have to practice also lots of questions from kinetic theory. Theory portion is this much only. So I'll practice questions tomorrow because because of Eid holidays, we couldn't have the class. So tomorrow IST, it will be 8 to 9:30 p.m. I'll take the class. So it would be 5:30 for you, KSA timings. 5:30 to 7 p.m. This would be KSA timing, I think. Please correct me if I'm wrong. So tomorrow, Monday,
Yes, ma'am.
we'll have the class. All right, so we'll practice all the questions of kinetic. So only question practicing will be there. If it is possible in 1 hour, we'll complete, or 1.5 hours, how much time is taken. Please revise whatever we have done today and come. All right, thank you so much, class.
Thank you, ma'am.